ChatGerry, a comparative study of CVD versus CKD using VMT and TDA models of 4 common stressors, number 1419, VMT sharp 743, TDA sharp 026, November 4, 2025, Gerald C. EclaireMD Foundation. Category, Comparative Pathophysiology. Preface, 2 major diseases shaped my life, 5 heart attacks from 1994 to 2004 and chronic kidney disease between 2010 and 2012. Both nearly ended my life but later became the focus of my research through my GH method, combining Viscoplastic Medicine Theory, VMT, and Topological Data Analysis, TDA. Although the heart and kidneys are different organs, they fail for similar reasons: excessive vascular pressure and metabolic stress. This study compares my CVD and CKD results to explore their shared mechanisms and unique differences in stress, strain, and system stability. Shared framework. Both studies use 4 common stress inputs: pulse pressure, PP, arterial stiffness and pulsatile load, affecting the heart, kidneys, and brain; mean arterial pressure, MAP, circulatory pressure, delivering oxygen and nutrients to organs; fasting plasma glucose, FPG, metabolic toxicity from insulin inefficiency; visceral fat percentage, VF%, inflammation and insulin resistance, linked to obesity. These represent 2 stress domains: vascular, PP plus MAP, and metabolic, FPG plus VF%. I analyzed their effects from 2014 to 2025, using both VMT, energy-based, and TDA, geometry-based, models. Key similarities. Both diseases show strong alignment between energy and geometry. The VMT energy plateau matches the TDA contraction pattern, proving that physics and topology describe the same process of biomedical system stabilization. Both reached equilibrium around 2020, when energy stopped accumulating and geometry became compact. Their energy shares were nearly identical. CVD, pages 26%, MAP 26%, FPG 25%, VF% 22%. CKD, pages 24%, MAP 24%, FPG 26%, VF% 26%. This symmetry means both organs depend equally on vascular and metabolic balance. The TDA diagrams for both show scattered clusters, from 2014 to 2018, that contract into tight, stable formations by 2025, signaling internal coherence and recovery. Most importantly, both conditions proved partially reversible through disciplined lifestyle control. Diet, walking, hydration, sleep, and emotional stability. Key differences. CVD occurred earlier, from 1994 to 2004, driven by acute pressure overload, while CKD appeared later, from 2010 to 2012, from long-term metabolic toxicity. In CVD, vascular stress slightly dominated, 52%, whereas in CKD, metabolic stress dominated, 52%. The heart recovered faster, reaching equilibrium by 2020, while the kidneys took a little longer due to slower microvascular healing. Unified interpretation. The human body absorbs and dissipates stress energy until it reaches viscoplastic equilibrium. When that limit is exceeded, irreversible damage occurs, heart attack or nephron loss. Once stress is reduced, the body stabilizes into a low entropy, steady state where partial recovery becomes possible. Both biological systems, cardiovascular and renal, have transitioned from energy accumulation to dissipation, evolving from scattered chaos to compact stability. This proves that chronic diseases follow universal physical and geometric laws. Conclusion. Despite affecting different organs, CVD and CKD share the same dynamic pattern. Both began as unstable high-energy systems, and later reached equilibrium through lifestyle correction. My CVD risk has stayed below 50% since 2014, and my CKD risk dropped from over 100% in 2010 to about 60% by 2024. Unlike cancers, which are cell-based diseases, organ conditions such as CVD and CKD are not irreversible endpoints. They are dynamic systems that can stabilize and partially recover when internal energy stress is properly managed through disciplined lifestyle control. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights belong to the author. Gerald C.